Hello guys, welcome back to my YouTube channel. And for today's video, we're going to tackle about the chapter 5, which entitled Internet from the Net Akad. So without further ado, let's get started. So the first thing that we're going to tackle is the Internet. So first, let me introduce you to chapter 5. So this chapter examines the characteristics and operations of internet as it has evolved from a shared media. So, con- contention-based data communication technology to today's high bandwidth full duplex technology. So, when we say Ethernet, so Ethernet is the most widely used LAN technology today. So, it is a family of networking technologies that are defined in an IEEE uh, 80.02.2 and 80.2.3 standards. So Ethernet standards define both the layer protocols and the layer 1 technologies. Ethernet is a way of connecting computers together in a local area network or LAN. So it has been the most widely used method of linking computers together in LAN since the 1990s. So the basic idea of its design is that multiple computers have access to it and can send the data at any time. So originally designed to transmit 3 Mbps as base network interface using Ethernet can now transmit data at 10 Mbps. So not other than that, so as our technology evolves, so I also research about the latest internet technology. So up to days now, it supports the data up to transmission of 10 gig per second. So that's how fast it is today. So that is basically all about the internet. So next thing that we're going to tackle is the MAC sublayer. So the internet MAC sublayer has primary two responsibilities, which is first the data encapsulation, and second is the media access control. So the data encapsulation process includes frame assembly before transmissions. So and frame disassemble upon reception of a frame. And in forming the frame, the MAC layer adds a header and trailer to the network layer PDU. So also the data encapsulation is the process of taking data from one protocol and translating it into another protocol. So that the data can continue across networks. So for example, a TCP/IP packet contained within an ATM frame is the form of encapsulation. So this data, also the data encapsulation provides three primary functions, which is the frame delimiting, the addressing, and the error detection. So the frame delimiting is the frame process provides important delimiters that are used to identify a group of bits that make up a frame. So this delimiting bits provide synchronizations between the transmitting and receiving nodes. Next function is the addressing. So in the addressing, the encapsulation process contains the layer 3 PDU and also provides for data link layer addressing. Next function is the error detection. So in error detection, each frame contains a trailer used to detect any errors in transmission. So of course, mainly the function of this is to detect an error if there is an error in each frame. So the second responsibility of the Mac sublayer is the media access control. So in the media access control is responsible for placement of frames on the media and removal of frames from the media. So as its name implies, it controls access to the media. So this sublayer communicates directly with the physical layer. So also the media access control is the sublayer of the data link layer. So in the 7-layer OSI network reference model, media access control is responsible for transmission of the data packets to and from the network interface card. So and also to other remotely shared panel. So basically that is all about the Mac sub layers. So the next thing that we're going to tackle is the switch packet forwarding method. So the first method is the stored and forward switching and the cut through switching. So first let's talk about the store and forward switching. So store and forward switching means that the LAN switch copies each complete frame into switch memory, buffers and computes a cyclic redundancy check for the CRC for errors. So in store and switching, in store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. During the storage process, the switch analyzes the frame for information about its destination. So in this process, the switch also perform an error check using the cyclic redundancy check or the CRC trailer portion of the internet frame. So next is the cut-through switching. So in cut-through switching, the switch acts upon the data as soon as it is received, even if the transmission is not complete. So the switch buffers just enough of the frame to read the destination MAC address so that if it can determine to which port to forward the data. And also the cut-through forwarding is a method for packet switching systems. So wherein the switch starts forwarding a frame or a packet before the whole frame has been received. So normally as soon as the destination address is processed. The difference between the store forward switching and the cut through forward is a store forward a store and forward switch makes forwarding decisions on a data packet after it has received the whole frame and check its integrity, while the cut-through switch engages in the forwarding process soon after it examines the destination MAC address of incoming frame. So that is all about the switch packet forwarding methods. So next, let's proceed to the ARP. Uh, Recall that every device with an IP address on an internet network also has an Ethernet MAC address. So when a device sends an internet ring, it contains these two addresses, which is the destination MAC address and the source MAC address. So the destination MAC address is the MAC address of the Ethernet, which will be either the MAC address of the final destination device or the router. And of course, the source MAC address is the MAC address that of the sender's Ethernet. So, to determine the destination of the MAC addresses, the devices uses ARP, and the ARP provides the two basic functions. So, resolving the IPv4 addresses to MAC addresses and maintaining table mapping. So, the main function of the ARP, or the address resolution protocol, as a network layer protocol used to convert an IP address into a physical address called the DLC address, such as an Ethernet address. A host which to obtain a physical address broadcast an ARP request on the TCP or the IP network. So, an ARP relies on the certain types of Ethernet broadcast message and Ethernet unicast message called ARP request and ARP reply. So the ARP protocol resolves IPv4 addresses to MAC addresses and maintains a table of mappings. So that's it for today's video, and so those are the important or the key information or the important terms, things that you will encounter in the chapter 5 of the NetAcad. So if you like this video and if you learned something and if this video helped you in your study, so please like and share and subscribe to my YouTube channel, and thank you for watching. Bye bye.